Ladies and gentlemen, welcome back. In previous video we talked about nomenclature of amines. So on this video we would like to talk about what makes properties of amine to be different. How does boiling point and solubility of amines and also basic properties of amine is affected by the structure of amines. So as you have seen this before, that if we have hydrogen or nitrogen, which is the case in amines, it is capable of making hydrogen bonding. You might remember that we discussed in chapter 9 that three atoms, if hydrogen is appearing on three atoms, then you observe hydrogen bonding in the system. And those atoms are oxygen, nitrogen, and fluorine. Hydrogen, which are appearing on these atoms, is capable of making hydrogen bonding. Now, what is hydrogen bonding? It's really dipole-dipole attraction, but it's a stronger form of dipole-dipole attraction. So let's take a look at methylamine. Do you see this bond? The bond between hydrogen and nitrogen is polar because nitrogen is more electronegative than hydrogen. So hydrogen is carrying a partial negative charge. And hydrogen, which has lost some of its electron cloud to electronegative nitrogen, is carrying shortage of positive charge. Shortage of negative charge. So it has partial positive charge. So two molecules of methylamine can make hydrogen bonding. Hydrogen with positive charge is approaching nitrogen with negative charge. So there is partial bonding. It's not sigma bonding. It's not pi bonding. It's not ionic bonding. It's partial bonding, much weaker than covalent bonding. However, this brings association between molecules. Molecules are attracted together. They are attached together. As a result, if we look at the boiling point of amines, we will see the boiling point are much higher than similar molecular weight of alkanes. So we're looking at hydrogen bonding here. This is methyl group. This is nitrogen, and these are the two hydrogens on the methylamine on the left hand side. The hydrogen from the other methylamine is making hydrogen bonding. You have also heard that the hydrogen bonding in our DNA is responsible for holding the shape of our DNA together. So if I go to next slide, you see the effect of hydrogen bonding on boiling point of amines. Now, what affects boiling point is association between molecules. If there is more interaction between molecules, we have to apply more heat to break down the partial bonding between molecules so they can evaporate. The higher the interaction between molecules, the higher boiling point. So we are looking at boiling point of methane, which is a nonpolar compound, minus 162 degrees of Celsius. Why? It has a mass of 16 grams per mole. It's not polar, and we know the only attraction between nonpolar forces, if you might remember, is called dispersion forces, or van der Waals forces, or London dispersion forces. They are the weakest attraction between molecules. Now, I'm comparing methylamine with methane. Look at the boiling point. The boiling point is minus 7, much higher than the boiling point of methane. Why? Because it has got two hydrogens sitting on nitrogen. They can make hydrogen bonding together. As a result, you need higher energy to break molecules apart from each other. That means higher temperature, higher boiling point. And if I compare the boiling point of methyl alcohol and methylamine, you see boiling point is much higher. Why? The reason is oxygen is more electronegative than nitrogen, so a stronger hydrogen bonding between alcohols relative to the amine molecules. That means higher boiling point. Now if I look at two carbon atoms, ethane has a boiling point of minus 89. So if I compare methane and ethane, ethane has higher molecular weight. The higher the molecular weight, there are more nuclei, there are more electrons, there is a stronger van der Waals forces, stronger dispersion forces. So you see, as molecular weight of nonpolar substances go up, comparing these two together, boiling point goes up because of increase of dispersion forces. What if I compare this amine which contains two carbon? Because it has NH, it can make hydrogen bonding. Look, boiling point is much higher. And if I compare this other similar molecular weight amine, which has got two carbons, boiling point is higher. Why? The reason is that one of them can make one hydrogen bonding. It has got one hydrogen. The other one, which has got two hydrogens on H, can make 2 times more hydrogen bonding. That means more interaction between molecules. That means there is more demand for temperature to break these bonds. Boiling point goes up. Now I'm going to compare again boiling points of amines and alcohols. Same molecular weight, almost same molecular weight. Alcohols have higher boiling point. Why? Because oxygen is more electronegative. Now let's take a look at 3 carbon atom system. Well, this is propane. Propane has 3 carbons. The boiling point is minus 44, which is much higher than the boiling point of ethane, which had 2 carbons. Higher molecular weight is going to bring higher boiling point. And looking at 3 carbon amine, which is the case here, the boiling point is 3. How come the 3 carbon system of propane, the boiling point is minus 42, and 3 carbon system of amine, the boiling point is much higher? Well, that is because molecular weight is heavier. Nitrogen has a molar mass of 14, and you have extra nitrogen here. That increases the boiling point. And if I look at this amine which has got 3 carbon, it also have an H. That means hydrogen on nitrogen can make hydrogen bonding. Do you see? Molecular weight the same, but because there is hydrogen on nitrogen, that makes it higher boiling point. Again, the reason is boiling point, and the reason is hydrogen bonding, increasing the boiling point. And this is another 3 carbon. I mean, how come this other one has got higher boiling point? Look at number of the hydrogen, 2 hydrogens on nitrogen, but here only 1 hydrogen on nitrogen. So 2 hydrogens can make 2 hydrogen bonding. 1 hydrogen on NH can make 1 hydrogen bonding. So this increase of the boiling point is due to the number of the hydrogens which are sitting on nitrogen. And then how about comparing this with similar alcohol? Comparing amine with alcohols. Alcohols always have higher boiling point. Why? If they have the same molecular weight, why alcohols have more boiling point? The reason is electronegativity of oxygen. Oxygen is more electronegative than nitrogen. So let's take a look at some of the boiling point of other amines, we are going to compare boiling point of amines with ammonia. Ammonia, which doesn't have any alkyl group on nitrogen, has a boiling point of minus 32.3 degrees of Celsius. And if I take one hydrogen off the ammonia and replace it with a methyl group, we have methylamine. Look, the molecular weight has gone up, the boiling point is going up. Add another carbon, that means higher molecular weight, and as a result, higher boiling point. Add a third carbon, the boiling point is still higher for two reasons. One reason is that this actually for one reason only, because 3-carbon system has higher molecular weight than 2 carbons. And if I look at this case, the benzene ring has got 6 carbons, you remember? Higher number of carbons have increased the boiling point to 184. Also, benzene ring is a flat ring, and it is not chaotic, it is organized, it allows for a better hydrogen bonding. While if I had 6 carbons which are moving up and down and they are open chain, they don't have the ability of making as much hydrogen bonding as when I have the flat benzene ring. And now we are looking at secondary amine. That means there is only one NH, one NH, one NH. What is happening? If I am comparing number of carbons here, in the first one is 2. Number of carbon in second one, 2 times 2 is 4. And number of carbon in third one, 3 times 2 is 6. Do you see? As number of the carbon are increasing, boiling point goes up. Again, effect of molecular weight. And these are tertiary amines. That means there is no hydrogen left on nitrogen. So 3 alkyl group, 3 methyl group of nitrogen, and 3 ethyl group of nitrogen. And this is a heterocyclic compound similar to benzene, except one of the carbons of benzene is replaced with nitrogen. What is happening? As number of carbons are going from 4 carbon to 6 carbons, boiling point is going higher. And in pyridine, boiling point is still higher because the pyridine ring is flat. And we have replaced a carbon with the atomic mass of 12 with atomic mass of 14, which is atomic mass of nitrogen. So that's how we interpret the difference between the boiling point of different amines. Is hydrogen bonding going to affect solubility of amine in water or not? Well, it depends. Depends how many carbon are inside the amine. If you have 1 carbon up to 5 carbon, amines are water soluble. But as you increase the number of carbons, as I increase the number of carbons, suppose this is N and this is H and H, can I say this is nonpolar? This is number of carbon chain. The larger carbon chain, the less soluble. Why? Because carbon chains are nonpolar. Water is polar. Nonpolar substances like gasoline, like wax, they don't dissolve in water, so they don't like water. They are hydrophobic. The NH2 part likes water because they make hydrogen bonding with water. So as you increase the nonpolar chain, solubility is decreased. Again, this is showing the reason for solubility. See, an H of amine is able to make hydrogen bonding with water. Same thing here. So these are two water molecules which are making hydrogen bonding with hydrogen which is sitting on nitrogen. So hydrogen bonding helps solubility of amines in water. So let's stop the video, try to answer this question. We'll come back soon. All right, thanks for coming back. Let's see, which one of these compounds has the highest boiling point? Well, let's check. This has no hydrogen bonding. This one, there is one hydrogen on nitrogen, so one H bonding. And this one has got two hydrogens, which is going to result 2 H bond. So can I say this must have the highest, number one has the highest boiling point. Does this make sense? Because there is more interaction between molecules. Next question, which compound is soluble in water? Oh, this is soluble in water. Why? The alkyl chain has less than 5. And this is also soluble in water because both of them can make hydrogen bonding with water molecules. But if we had 6 carbons there, we would say hardly soluble in water. Okay. Do you remember when we talked about ammonia previously, we said this ammonia has got a lone pair here. And we said, if you look at the definition of acids, we define this as a Lewis acid. Lewis base. Why is this Lewis base? Lewis bases we define as donor of electrons. So do you see? Ammonia can donate electrons. It can break the bond between oxygen and hydrogen. So hydrogen is now bonded to nitrogen. It makes NH4. Electron pair are gone on oxygen, so you make OH minus. Why is this basic? Ammonia is a general cleaning solution in kitchen. Why? Because most of the stains are result of fatty acids which are going to bond between the dirt and surface. So if you have a base, you can neutralize fatty acid, and if you do, you make salt of fatty acids, and salts are soluble in water. So anything which can result formation of hydroxide is basic. So ammonia is basic. Are amines basic or not? Yes, they have the same thing. There is lone pair here. They can be donor of a lone pair. They can break the water molecule, produces hydroxide, and you make the positively charged nitrogen. Positively charged nitrogen. In this case, ammonia was converted to ammonium. The positive charge, ium, is the sign of positive charge. So this is ammonium hydroxide. This is methylamine. And if it's dissolved in water, is going to produce hydroxide, and it makes methyl ammonium hydroxide. So this is soluble in water. This is soluble in water. Okay. So have you noticed most people, when they are eating fish, they add lemon to it? Why? Well, lemon has citric acid. The citric acid is going to neutralize amines which are produced by decomposition of the amino acids in fish. The foul smell of fish is because of the amines. So you neutralize amines, the acid in lemon is going to neutralize the amine. Those volatile amines are going to be neutralized. The fish doesn't smell as bad. And this is the reaction. It's not reaction of methylamine with citric acid, but it's a reaction with hydrochloric acid. So what happens? Again, the basic properties of amine are going to pick up the hydrogen. So you make methyl ammonium, and then Cl minus is bonded with the positive charge. It's an ionic bond. So we call this methyl ammonium chloride. Thank you for paying attention. On the next slide, I'm going to show you how formation of salt of amines, how this reaction is used in making pharmaceutical products. For now, take care. See you on the next video. Thank you, guys.